Hey, I'm Mitchell. Welcome to another video in the RSP Education series. Imagine this, machines on the factory floor having real-time conversations. No middleman, no delays, just lightning fast communication. Welcome to the world of peer-to-peer topology, where every device can talk directly to another without needing a central controller. In this video, we're going to break down how this powerful communication method is transforming motion control, real-time automation, and distributed systems. If you've ever wondered how two VFDs can sync without a PLC in the middle, this is a video for you. If you like this kind of content, want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Always consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So in a peer-to-peer topology, every device or node on the network has equal status. Each node can initiate communication with another node directly without needing to go through a central controller like a PLC or a SCADA server. Think of it like a group chat where everyone can message everyone else directly, no admin approval required. In industrial environments, peer-to-peer topology is commonly used to enable real-time coordination between field devices, also to allow controllers, drives, sensors, and HMIs to communicate without central supervision. It also reduces latency by eliminating polling, data gathering, or master-slave cycles. This setup's often used for time-sensitive control systems, distributed control systems, or machine-to-machine interactions. So how does peer-to-peer topology work? All devices are equal participants in the network. Any device can initiate communication with any other. There's no centralized controller. Some example protocols that you're going to find with peer-to-peer is Ethernet IP, Profinet, CAN Open, OPC UA, and its use case in industrial automation is going to be, for example, imagine a scenario. We got two VFDs synchronizing motors. So in a peer-to-peer network using Ethernet IP, a VFD is going to produce its speed and torque data. That's VFD A, for example. VFD B consumes that data to match its motor speed. Both VFDs communicate to each other without a PLC getting involved. What's the result? Faster response time, better synchronization. So some pros of this peer-to-peer topology is its speed, right? Direct communication reduces overhead. Its scalability, more efficient for large distributed systems. Reliability, there's no single point of failure. Real-time control, ideal for motion and coordinated tasks. Some cons though, it's more complex of configuration, right? More advanced network setup is required. Traffic management gets a little dicier too. It can become a bit chaotic if many devices are going to communicate simultaneously. Security is always on especially IT's mind. It requires solid rules to prevent unauthorized or unsafe communication. Diagnostics can be more of a pain, right? They're harder to trace communication issues. Peer-to-peer topology and automation. We have Profinet. It supports peer-to-peer communication by enabling devices to communicate directly without a central controller like we discussed. This is perfect for flexible and distributed automation systems. Ethernet IP, it allows peer-to-peer communication using CIP, which stands for Common Industrial Protocol, making it suitable for distributed automation applications. EtherCAT, this is going to use a distributed clock mechanism and allows devices to process data on the fly, enabling efficient peer-to-peer communication in high-speed automation systems. OPC UA, designed for interoperability, and it also can support peer-to-peer communication in a client-server model, making it ideal for Industry 4.0 and smart automation systems. So to summarize, peer-to-peer topology allows autonomous, decentralized communication between devices. It reduces latency and boosts system responsiveness. Very common in modern protocols like Ethernet IP, Profinet, CAN Open. Best used in motion control, safety systems, and real-time applications. To recap, peer-to-peer topology is going to allow devices to communicate directly without relying on a central controller. Fast, reliable solution for real-time control, motion systems, distributed automation, using protocols like Ethernet IP, Profinet, and CAN Open. Although it does require more advanced setup and careful traffic management, the benefits in speed, scalability, and system responsiveness make it a powerful option in the right applications. For hundreds of thousands of other industrial automation products, go to our website, rspsupply.com, the internet's top source for industrial hardware.